Hi, and thanks for having me. My name is Lindsay Silver, and I'm the head of platform technology at Condé Nast. I'm really excited to be here today to talk to you about data and AI and product development, and to kind of go through how we think about it at Condé Nast. So first, a bit of context. Condé Nast is better known as the home of brands like Vogue and GQ and The New Yorker, Allure, and Architectural Digest. We're a 100-year-old magazine company that over the past 20 years has had to go through a transition from being a company that produces written content and photography around the world to one that creates dozens of digital products. So by the numbers, we're about 72 market brands around the world. That would be Vogue in France or GQ in Russia. We have about 185 web, mobile, and OTT products. Those include things like the New Yorker crossword app or Self Magazine's website and web properties. Across that network of products, we have about 350 million monthly active users, about 450 million to 500 million in annual digital revenue, and between 5,000 and 6,000 editorial users. So let's talk a little bit about how we build products at Condé Nast, because I think it's important, regardless of what the features are, to sort of discuss how you think about products in an ecosystem like ours. So obviously, if you think about our audiences at the top of this chart, we have audiences of all kinds. We have audiences in specific markets with specific interests and specific utilities and products that we need to service. What we find about those products and those audiences is that the products they use have to be different. But the tools, the APIs and technologies, the data and infrastructure often don't. And a lot of times when we think about feature development, we're thinking about how do we build a tool, an API, or a technology that services the biggest number of end products. And so we've built this model that's sort of two-dimensional, where we have our portfolio of consumer products across the top. We have teams that support those individually. And then as we go down the stack, we've built different tools and teams and organizations focused on different levels here. So we have teams within our what we call our global platforms that are responsible for things like content management or ad systems. We also have teams lower in the stack that are responsible for data architecture and how we manage our APIs and technologies. And what we found is we generally have a smaller number of teams per organization as you go down the stack. And so our platform teams, basically the same size, that's the 4 levels below, are basically the same size as our single consumer product team in terms of the number of people we need to actually develop. Okay, so let's talk about developing AI-driven features or data-driven features. At the core of any data-driven feature is a feedback loop. Actually, at the core of almost anything that we do that involves thinking, whether it's artificial thinking or human thinking, is a feedback loop. But assume that for any feature that you're building that's AI-driven or data-driven, you're talking about a feedback loop. And I think that is a really important thing that people don't sort of boil these down to. But basically what we're talking about is some sort of action or some sort of feature that is on the page that a user sees, some sort of signal that comes out of that feature that's synthesized by a machine that then leads to a decision about how to change that feature or to improve the experience, and then the cycle starts over again. There's a test, there's some sort of conversion measured that's synthesized by the computer again, or by some sort of model, and then a decision is made, and then actions happens. Now, this is, of course, very general. I mean, this is how you live your life, probably. You're constantly trying out new foods, deciding if you like them, applying the tastes and to your historical knowledge of the foods you've eaten, making a decision about whether you'll eat them again, and then maybe eating them or not eating them next time. That's almost universal in terms of thinking. What's interesting about building features that are AI driven is that you just have to think about it in terms of how a computer thinks, or how to build these things in a way that allow computers to think about them. So starting with that action, systems like your multivariate testing platform that you might use, your ad servers, all of those personalization engines are built so that they can actually serve features in this way. So we use a multivariate testing platform called Wasabi that was open sourced by Intuit. We've modified it a little bit to allow us to do tests that are self-optimizing. But it effectively serves a lot of our feature variations. So if we want to test two button colors, if we want to test different recirculation algorithms, systems to decide how to rank content, we can use Wasabi to do that. Once we've deployed a feature with Wasabi, the next step is for a sort of a set of systems to synthesize the information that comes out of that. So we synthesize data, and we'll talk about it in a sec when we get into the domains that Conde has. We synthesize data about our content, so we extract things like keywords and entities and topics. We synthesize data about our users, so that might be building models of propensity or likelihood to subscribe. And we synthesize data about our advertisements and our monetization options. So that might be whether we should show let's say, a house ad or a marketing ad or a commercial ad to a specific user at a specific point. All of this data is held that we store in various data systems, and we're doing this in real time as articles are published or as users come to our sites. When we need to make a decision, then that usually is when you're visiting our site and we're trying to decide what to do with you or what to show you. We pass all of that data into some sort of predictive model, and this is when you hear people talk about ML. A lot of times they're talking about the models or the systems. Usually there's an API on top of them that make predictions based on data that you pass into them. And so in the example that I've sort of given around recirculation or getting people to click on pieces of content that send them around your website, we would use a predictive model that tries to guess what content you're most likely to click on. And different models that we have, and we run a few dozen of these models at the same time, depending on the type of user you are. We will pass data about the context, about what article you're viewing. We'll pass data to those models about what we know about you historically. Do you usually click on articles about kittens or about sports or about fashion? And then we'll pass data about the advertisement or monetization options we have. So are we in Q4 and are we trying to do a lot of commerce, or are we trying to push for a lot of sort of top of funnel brand lift type campaigns with some of our partners? All of that data goes into these predictive models, and those send back a set of articles or a ranking for those pieces of content. We pass that back to our systems, our multivariate testing systems, or our personalization engines, and those actually render the page based on what you've said. That happens again and again, over and over again, millions of times per hour for Condé Nast, and we're actually making these decisions over and over again. And what's cool about that, and why I fell in love with this type of feature, is that if they're set up correctly, every time this happens, every time that you go through this feedback loop, you're actually improving the system just a little bit. And so when we deploy a new feature, we have zero data and signal about how it will perform. But as these things happen, we're actually building a better and better system. And historically, this was done kind of manually. When you hear people talk about retraining models or pulling down and redeploying models, that's speaking manually about the improvement of that feedback loop. More recently, a lot of the models we use for recirculation and for advertising and for defining user propensity are auto-updating, and so that means that that every time someone views something, or in a lot of cases every certain time intervals, let's say every hour, the models are retrained, and that means that this improvement is happening behind the scenes. The models are getting better and better and better without us actually doing any work ourselves. And that I think is the key to this type of model in the context of companies like Facebook or Google or a lot of the big media companies now, is that these models are designed in such a way that they add value to the company incrementally without much additional human interaction. You kind of have these cooks in the kitchen sort of adjusting things and making sure that the levers are sort of pulled the right way, but you don't actually have incremental development going on in the same way that you would with a completely human-driven model, feature. So this is kind of the core of AI-driven models. Now, this doesn't go into the technicalities of building these too much. I can tell you, basically, we use a system. We model these in specific domains, which I'll talk about. So the really interesting thing happens with feedback loops when you turn them on their side, and I think this is the core, the reason that AI-driven features have taken such focus over the last few years. When you have built a feedback loop like this, just like when you build a really high-performing team developing features in general, every time you go around this feedback loop, you get slightly better at what you're doing. And so if you take the example of our Vogue recirculation models, every time we go from act to synthesize to decide to act, we know a little bit more about our audience and our users. And that's not because our teams know more, it's not because people have become more seasoned in their jobs, it's because we have a stronger signal and more data within our models or that we have trained our models with. And so we're constantly retraining our models, and that adds this incremental value that makes them better and better at their jobs. And if you look at Google or Facebook, you'll see they've built their whole businesses on this model of incremental improvement that's automated because of the way that their ML systems are set up. And it's really cool. It's actually the core. It's sort of what the root of my curiosity about these features and the reason that we've driven to build several or so many of them within Condé Nast. Okay, so the second thing to know about AI-driven feature development is that it relies on an understanding of your domain. And just like the feedback loops from before, understanding your domains is something that's obviously really important to developing any feature. But when you're building an AI-driven feature, knowing what your domains are is important because you need to translate those into things that the computer or the servers that are making your recommendations understand. So the way we look at this at Condé Nast is in terms of the three major domains that we have to deal with. And the names sometimes fluctuate when we're discussing things, but roughly they translate to our content as our first domain. Our content represented by a content identifier or an image identifier of some sort, and with traits, things like who wrote the content, what the content is about, what keywords are important to the content. All of these are traits of a piece of content, and when we look at our content model from a data standpoint, there are hundreds and hundreds of traits for each piece of content. Our second domain is obviously our user base, and for almost any business, users will be one of the domains that you need to understand, or the areas, the data that you need to understand. Our users are usually represented by some sort of ID, whether it's a session ID for anonymous users or an email or hashed email address for users who we have seen. And that's important because obviously we need to be able to link an individual user to individual piece of content they've seen, or propensities that they have, a propensity to subscribe or a propensity to view additional content. But there are dozens of other traits that we have. We derive a lot of first-party traits about our users, what types of content they're interested in, how often they come to our sites, and we use those when we're building AI-driven features. It's really common to have a model that takes and associates a piece of content with a user who might want to read that type of content. The third domain we have, sometimes we call it monetization, sometimes we call it our ads business. Here I'm calling it our experiences. Those are the actual context, the actual applications that are represented that tie together content with our users. And they are important because they stand alone. If they were just pieces of content, we wouldn't need this, but a lot of times we'll show a piece of content to a specific user across their mobile device or a mobile version of our sites, across our desktop versions of our sites, possibly within a mobile application, sometimes even with our videos within other media like our set-top box applications and other places. And I apologize, there's a low-flying airplane above me right now. Basically, our first goal, and something we tell any product manager who's in this space, who's thinking about these types of features, is they need to understand these domains that they're working with. Not every feature needs to understand or needs you to understand all three of these domains, but you definitely need to understand any domains that are related to your feature. Good example here is a feature that we released fairly recently that took and auto-recommended editorial tags to our editors. So in that case, we needed to understand the individual editor, what tags they'd used in the past, what types of content they'd written, and then on the other hand, we needed to understand the pieces of content that they were potentially writing. So we had to have our NLP systems extracting keywords and understanding that content. It's important for the folks designing those features to understand both of those areas and how they might relate to each other, so you can come up with a hypothesis. That brings me to step 2, which is how these things relate. So it's obviously extremely important for anyone building a feature that does recommendation to understand what they're recommending, on what basis you might recommend something. And a good example here is in something that happens a lot is that we can come up with false causation. Food content's a great one for this. So when we started doing a lot of food content recommendation, we really tried to look at what a user might have looked up before, what ingredients they wanted, all kinds of really deep information about our users to build our recommendation model. On the content side, we needed to understand what ingredients were in our content, all kinds of things. And we came up with a pretty complex model that tried to do personalized recipe recommendation. What we found over time, after testing a few variations, was there were actually other contexts that are way more important to this than users' past behavior. The biggest one was time of day and day of the year. So when we started looking at what content worked the best, what we found is specific content, specific recipes work way better at different times of the year. And that was actually what we consider an experience or a contextual attribute. Time and also geography are a lot of times we consider those contextual. So we actually started building models for recipe content that took into account day and time as one of their attributes, and what times and days that content had performed well in the past. And that actually increased our click-through rate substantially on those types of recommendation models. What's interesting here, and you can obviously take this as many degrees as you want, but I think that step 3 is the interesting one, which is asking yourself when you're building a feature how that feature relates to all of your other domains that are involved. And so a good way to look at this is if you start with your subject, in this case, let's say it's your experience, how does a specific experience relate to a specific user with specific content is a question we ask. How does, if we create an inline link serving module, which we do a lot, we do automatic hot linking within our sites, how does that apply when the content is about a certain subject and is being applied to a different audience group? And that actually is the foundation for a lot of the hypotheses for features that we build. We rarely say something is going to be so powerful that it will affect all users in all content or all contexts. But we do focus down on as many user groups as we can in as many content types, or as many content types with as many users, and in looking at as many experiences. That kind of gives that ubiquity that we talked about earlier when we were talking about how to build a platform. Obviously, the broader and maybe a general concept in AI is sort of generalized AI. That's computers' ability to handle a variety of situations. And the holy grail for machine learning engineers at somewhere like Google is to build systems that solve really general problems. The same goes here. The wider the context, the more problems you can solve with a model, the better you are. So we obviously strive for personalization models, let's say for our pages, that are as broad as possible. But usually those are actually much more segmented. Usually we'll find a model that works really well for a set of people in a specific context, and that's okay. But you need to understand deeply what you can do with each of these, how users are identified, how content's identified, how you know where you are in an experience, and then what data does the computer have to work with related to that context. Cool. So I mentioned these. This will be a quick one. I think it's important to specify the key ingredients for building an AI-driven feature. So as I mentioned a couple times, everything we have in any domain has an identifier, and it's extremely important when you're building anything that are related to data, that you can somehow identify that domain really uniquely. So a user always needs to be identified uniquely, a piece of content needs to be identified, and then what we call the context, or the page of a website, or the screen of an application, or the specific spot even within a page needs to be identifiable, and that allows you to attach traits and information that you know to those. And so in our case, our traits, as I said, are in the hundreds for our users, in the tens to hundreds for our piece of content, and definitely in the tens at least for our experiences or our advertisements. And then last, as I sort of talked about at the end of the last slide, are the relationships. So every piece of content has a relationship to a user who's looked at it. They've either scrolled or they haven't scrolled. They've bounced or they've clicked to another page. Those are things that relate to, those help you understand the user's relationship with a piece of content and allow you to build a feature off of that. With these things and thinking in terms of these domains and in terms of those feedback loops, you can build a whole myriad of features. And next I want to just take you into kind of what these AI-driven features might look like at Condé Nast. Okay, so let's talk about some of the features that Condé has built a little bit more. So the first is personalized recirculation. So about 3 years ago, we started doing personalized recirculation. That meant looking at things we knew about our user domains and about the context. So the time of day, as I said, was one of the aspects, but things like what platform you were on, where you were looking, where you were viewing the content, and using those to actually personalize our recommendations for recirculation. I think when we talk about recirculation, we include things like hot linking. And I think one of the more interesting applications of this was a system that we built to extract entities from our content, like names, Tina Fey and Amy Poehler in this case, and then actually look for content within our sites that was most relevant to that user about Tina Fey or Amy Poehler, and actually auto-link that content back. And so at the end of the day, the user, when they clicked on this piece of content, would be redirected to another article about Tina Fey that then also took into account things that they knew. And we saw some really interesting things happen with some folks where content actually was linked that was related to something else they'd been reading. So if they were interested in the Met Gala on Vogue, you might see this Tina Fey article actually linked to an article about Tina Fey at the Met Gala. Now, obviously, there are a lot of parameters to this. You don't want to link to an extremely old piece of content. You don't want to link to a piece of content where Tina Fey's name might be mentioned a lot, but which is about someone else or something else. And so when you're building these models, there's a lot to think about, and that's why this deep understanding of your domains is really important. The other thing that we think about when we create features like this is how do you validate them? So how do you watch and make sure that feedback loop is actually closing and improving every time? And with this feature over time, we saw it improve a fair amount, although what we found was that it kind of plateaued after a little while. You couldn't get these just straight personalization features with a single model or a universal model to work any better than, about 10% better than when they started. So what we did, and what applies to a lot of the features that we've done now, is that we actually treat them as families of models. And so when we try a model that might be what we would call a personalization model, we may have 5 or 6 variations of that model, and we're running at the same time using what's called a multi-armed bandit. Those models in parallel, and we're testing them against different cohorts of our audience. So we're actually doing experiments with multiple models at the same time. And for some people, the most popular article about Tina Fey might always be the one that wins. For other people, we may test a contextual model that really targets what they've read before. And at different times, those will work for different audiences. And so that layered approach is really important to making this type of system successful. Another area that we've really honed in terms of this is our experience optimization. So we know that different users and different contexts or different experiences respond to placements of content in different ways. And so there was a whole study maybe 5 years ago, a human-driven study that found that slide ups from the bottom of pages actually had a pretty significant positive impact on users. What we found over time was that depending on the situation or the time or the type of device you're on, actually those are detrimental. They increase bounce rates or exit rates. And so we've built a system or a set of systems that allow us to run those experiments in parallel, and then using that same multi-armed bandit or auto optimization algorithms to actually change where these things are placed based on the person, based on the device. And a lot of times those are sort of black boxed. We put in a lot of information about the context. Again, what a user is using to view the content, what content is on the page, what time of day it is, what we know about the user from the past. And the models will spit out versions or responses to that, placements, and without actually giving us a full explanation. And so over time we've sort of honed these models and improved them, but they constantly are getting better on their own. So as we retrain, as we get a stronger and stronger signal, we're seeing increases in click-through rates and response to these types of units. Third area that Condé Nast has had a lot of impact, or sort of AI-driven features have had a lot of impact in, are our pushed content. So in addition to changing the order of content on our emails and our notifications, we're actually using AI now to make decisions about when we send email, what ads are served in that email, and in some cases even whether we're sending email or not. We're timing out users, or we're decaying the number of emails that we send to users over time based on their likelihood to open those, and also based on things like what content we know they've enjoyed in the past. So a lot of times, and in some of our bigger newsletters now, we're making decisions based on the content in the newsletter, what audience will get it, and those are all dynamic. If you've never clicked on an article about politics, let's say, and we have a heavy newsletter about politics, we'll actually adjust downward your likelihood of getting that email. And it's still probabilistic, and it's still, we still include audience in there that we think is low likelihood of opening, mainly to test and to validate those models. And every time we do that and they improve, we've got something that helps our AI-driven feature improve. So we're always thinking in terms of how to build those features in a way that gives us that signal back and improves the signal. So the next feature is less of an explicitly AI-driven feature and more of a feature that allows us to power more complex AIs within our applications, and that's one of advanced interaction. So the label is a little bit abstract, but the concept is basically that when you're building features that take data about your users or about their context and then synthesize it and make decisions, the more the proprietary the information is and more specific to your experiences, the better. And so with brands, especially brands that are kind of specific in their outlook, things like Golf Digest or Brides, we need to get information that's specific to those users. And so over the years we've done a lot to actually get information about people that isn't necessarily that general information, their age or the time of day or things that, just the real basics. Golf Digest is one where we got a lot of information early on that I thought was really cool. We were able to find people's favorite club types, the courses that they enjoyed, specific shots that were difficult to them. And then what we could actually surface content and surface information for them that actually was really relevant to their level of play and their interests. And that's it. I know this was pretty high level, and I'm happy to delve into more detail when in the question and answer section, or feel free to reach out to me by email or on LinkedIn. I look forward to hearing from you. Bye.